Suppose I have one of those old school combination locks where you spin the individual wheels, and if the numbers all match up to the combination, you've unlocked it. In this case, the combination would be 2471. I could unlock this and take my bike and ride away. Of course, you probably don't want to use one of those anymore because you could just clip the cable very easily. They're not very secure. But you might ask, how many combinations on this lock are there? But we probably don't want to use the word combination. Let's say, how many digit passwords are there? So you could start listing them: 0000, 0001, 0002, 0003, and etc. all the way up to 999899999, and then just count up how many of them there are. Well, we have 1, 2, 3, 4, 5. You get the idea. This would be 9999, and then we come around here and we call this one number 10,000. So we have 10,000 possible lock passwords. Notice here in this situation, order matters because 0001 is not the same as 0010. If this is the passcode and you enter this, it is not going to open. So order matters here. Short of adding them all up, what is the easier way to figure out how many total lock passwords there are? The way to do that, observe that there are 4 separate wheels. Each wheel has 10 choices for this one, 10 choices for that one, 10 choices for that one, 10 choices for that one. So you multiply those and you get to 10,000. So this is what we're going to call a permutation. Permutations are when order matters. I have been trying my best not to call these combinations, even though we usually refer to these as combination locks. They should actually be called permutation locks because order matters in a permutation. Permutations can be used to answer questions like, how many 3-letter words can I form with 26 letters of the alphabet? There are 3-letter words, so 1, 2, 3. And for the first choice, there are 26 letters. How many are there for the second choice? Well, you also have 26 here. And for the third one, that's right, 26 for that one too. This is assuming that a word is something like ZZZ or AXQ or something like that. But if you multiply those, 17,570, 6 possible words. And again, order matters here because THE and EHT are different words. Your brain might read that as the, but it's actually different in English. In this situation, you're going to get a lot of words you can't possibly pronounce. So you might go ahead and ask, what about if the middle letter is a vowel? So you still have 3 letters here. Let's be a little more specific here even. The middle letter is a vowel and the other 2 are consonants. We're stuck with a bit of a difficulty here because vowels, A, E, I, O, U, but do we include Y? I am going to make the very controversial decision here and say that we're going to include Y for the simple reason that any word that was a consonant, vowel, consonant that had a Y in the middle, we could probably pronounce. The consonants are all the letters that aren't vowels, but because it's pronounceable, do I include Y here as well? My answer is yes, why not? So I'm going to have a total of 6 vowels and 21 consonants. To say how many of these there are, the consonant has to come first. There are 21 possibilities for that. There are 6 choices for vowels in the middle and 21 choices for consonants at the last letter. 2,646 words. If all of those are .com URLs, I'm pretty sure they are all taken, but go ahead and try a few. You get words like ziz and zik and zuv, just to name a few. Suppose there are 12 countries I want to visit, but I only have enough vacation time and money to see 3 of them. How many itineraries can I make? An itinerary, we're going to assume that order does matter, because visiting Albania before Botswana is different than visiting Botswana before Albania. 3 countries I want to see, 1, 2, 3. How many choices do I have for the first one? 12 choices for the first country. Now, how many choices do I have after that? Well, travel logistics notwithstanding, there are not 12 countries anymore. There's only 11 because it's assumed that I've already visited this country, so I'm not going to revisit it. So there are only 11 choices left, and then 10 after that for a total of 1,220 possible itineraries. Now is the point where you might be asking, this is interesting, but how can I write a shorter formula? Well, if you are doing a permutation with no repeats, there are n over n minus k possible permutations. But here I am using the exclamation point because I'm very excited, but there's a second reason. This is the factorial function. What it means is when I do something like 5 factorial, that means I have 5 times 4 times 3 times 2 times 1. If I have 10 factorial, that means that is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But it bears repeating that this means I have permutations without repeats. So the first examples I used here, these don't work because here in this one I could use the same number over and over again, and here I was assuming I could use the same letter over. I can modify this example so that I was not allowed to use the same letter more than once, but why bother? Let's move on to a different example. I have 9 cats. I want to photograph 5 of them. Cats are picky, so the order I do this in matters. As you know, if you ever tried to round up cats for the vet and you get the wrong one in there first, all the other ones immediately run and hide. How many permutations of photo shoots are there? This is not as complicated as it sounds if you just use the formula directly. I come back here, n over n minus k, both of those factorialized. I say here n is 9. I have 5 is k. So I just put these in the formula. 9 factorial over 9 minus 5 factorial. Notice this factorial is after the subtraction. I have to subtract first and then use it. And something fun kind of happens here. I get 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 9 minus 5 is 4. So I get 4 times 3 times 2 times 1. And now something fun happens, where this whole thing cancels out this whole thing, and I just get 9 times 8 times 7 times 6 times 5 is going to be equal to 15,120 possible little furball photo shoots. Isn't that exciting? You don't have to use the formula here. You could just say you have 9 cats, you want to photograph 5 of them. So how many choices are for the first cat? Well, for the first cat, you have 9 cats you could pick from. For the second one, you have 8 left because you already took a photo of one of them, and then similarly 7 for the next one, 6 for the one after that, 5 for the one after that. So this formula gets pretty important when we talk about combinations, not permutations. But for permutations, you can pretty much always just do how many objects do you want to do, how many possibilities are there for each one. If you're not allowing repeats, just decrease the numbers each time. If you are allowing repeat, just keep the numbers whatever they are.